It wasn't war that brought Earth to its knees. It wasn't an asteroid from deep space. It was something older, something from beneath our feet. The land itself turned against life. Forests caught fire, rivers dried, the very air became poison. But below the waves there was silence. For a time, there was safety. This is the story of a world that was no longer safe to walk, when the continents emptied of life, and only the oceans remained. A time when survival meant fleeing inland, not toward land, but away from it. This is not science fiction. This is the story of Earth's first true apocalypse, the end of the Permian, and the only time in history when the oceans were the only safe place on Earth. But even the oceans couldn't hold out forever. So what went wrong? 259 million years ago, Earth was in the grip of a supercontinent, Pangaea, one landmass to rule them all. From pole to pole, a single, massive slab of tectonic unity. But that unity came with consequences. The interior of Pangaea was a desert, not the kind we know now, but a wasteland, hot, dry, and deadly. Monsoons pounded the coasts, but inland, rain barely reached. Temperatures could swing by 40 degrees between day and night. Winds raged without mountains to stop them. Yet, against all odds, life flourished. Giant forests of glossopteris trees anchored river valleys. The land was filled with gorgonopsids, dicynodonts, and pariasaurs, early mammal relatives that hunted and grazed across the terrain. The seas brimmed with brachiopods and ammonoids, corals and reef systems, and creatures we'd barely recognize today. This time in history was called the Lapingian Epoch, the final chapter of the Permian period, a golden age for life, right before the darkest hour. But how could such abundance hide such vulnerability? And why did the planet, after 300 million years of evolution, begin to unravel? Before the end came the peak. The Permian wasn't just full of life, it was full of diverse life. Synapsids ruled the land, not dinosaurs, not reptiles, but ancestors of mammals. They had advanced jaws, warm-blooded metabolisms, and in some cases, fur. The oceans were ecosystems of complexity. Reefs stretched for thousands of kilometers. Trilobites, which had survived since the Cambrian, still held on. Ammonoids evolved into dozens of forms. And on land, insects had taken to the skies. Some dragonflies reached wingspans of 2 feet, possible only in an oxygen-rich atmosphere. Oxygen levels were near 30%. That's nearly 10% higher than today. Fires were common, but so was fertility. Everything was thriving, on land, in water, in air. But this balance was built on a knife's edge. What if the oxygen dropped? What if the carbon rose? What if something deep within the Earth shifted? It began in silence. In what would become central Siberia, a rift opened in the Earth's crust. Magma surged upward, not once, not twice, but in waves. These eruptions didn't last decades. They lasted hundreds of thousands of years. Today we call them the Siberian Traps, one of the largest volcanic events in geological history. The land didn't just erupt, it transformed. Over 7 million square kilometers, an area the size of Australia, was drowned in lava. With each eruption, carbon dioxide flooded the skies, global temperatures climbed, ice caps melted, methane released from the permafrost, creating a runaway feedback loop. The Earth was no longer just warming, it was choking. Oceans began to acidify, rain became toxic, plants couldn't photosynthesize. What would happen to the creatures that needed stability when the planet offered none? Even as the land turned deadly, the oceans endured. Beneath the surface, temperatures were cooler. The vast thermal mass of the water absorbed the worst of the heat. Coral reefs still built their towers. Small fish still darted between them. Plankton, the invisible scaffolding of ocean life, still floated freely. For a time, marine ecosystems acted as Earth's last refuge. The oceans weren't untouched, but they were less touched, but they were changing. CO2 dissolves into water, turning into carbonic acid. Over time, shells thinned. Coral growth slowed. Nutrients stopped cycling as water layers became stratified. These were early warnings. Could the oceans continue to protect life, or would the poison reach even here? Above the sea, survival became impossible. Rainfall patterns collapsed. Rivers dried. Ancient forests, some hundreds of feet tall, disappeared in waves. The sky, once rich with oxygen, was now filled with ash, dust, and CO2. Ozone weakened. UV radiation poured through. Entire ecosystems blinked out. Some species went extinct before they were ever fossilized. Creatures tried to migrate, to adapt. But where would they go? The deserts expanded. The forests retracted. There was no sanctuary. On land, the death toll was absolute. Almost 70% of terrestrial species disappeared. Could any animal survive when the very air turned against it? As land life vanished, the oceans became the final refuge. But the oceans were changing faster than they could sustain. As surface temperatures rose, the water stratified, separating into layers that no longer mixed. Without mixing, oxygen couldn't reach the depths. Massive dead zones formed, entire regions of ocean where life suffocated in silence. But it got worse. Some bacteria, thriving in low oxygen conditions, began to release hydrogen sulfide, a gas toxic to nearly all life. It seeped into the atmosphere, poisoning land species already on the brink. Even the oceans, the last holdout, had begun to die. 252 million years ago, the Earth crossed a line. It's known today as the Great Dying, the worst mass extinction in Earth's 4.5 billion-year history. 96% of marine species, gone. 70% of land species, gone. Coral reefs vanished for 10 million years. Trilobites, creatures that had survived every catastrophe since the Cambrian, went extinct. The Earth was nearly sterilized. It took 10 million years for ecosystems to stabilize again. Can we even imagine that scale of loss? Could any intelligent species survive such devastation today? A few creatures made it through, not by strength, not by dominance, but by resilience. Lystrosaurus, a pig-sized synapsid, survived by burrowing, by hiding from heat and radiation underground. It became the most common vertebrate on the planet after the extinction. In the oceans, simple organisms like bacteria, crustaceans, and deep-sea creatures held on. Not glamorous, not dominant, but adaptable. And from these survivors, new branches of life began. Life had been reset, and this time, it would grow differently. The Permian ended in fire and silence, but silence is not the end. Over the next 10 million years, the Triassic period began. Volcanoes quieted, the atmosphere rebalanced, new ecosystems emerged from the ruins. Small reptiles evolved into archosaurs, the ancestors of crocodiles, pterosaurs, and dinosaurs. The first true mammals appeared, tiny and nocturnal. Life didn't recover the same. It became faster, more specialized, more efficient. Out of extinction came evolution. The Great Dying wasn't caused by an asteroid. It was caused by carbon, by climate change, by warming, by Earth changing faster than life could keep up. Today, we're releasing carbon at a rate faster than the Siberian Traps. Ocean dead zones are increasing. Temperatures are rising. The oceans saved life once. But what if they're dying too? What if there's no refuge left? Earth remembers what we forget: the silence after extinction, the fragility of balance, the cost of too much, too fast. Once, the oceans were the only safe place left. But there is no place to run anymore. What happens next is up to us. Subscribe to Life Before Us, and join us in remembering the worlds that came before, so we can understand the one we live in now.